Hi guys, welcome back to our networking series, and in this episode we shall be looking at OSPF. We shall configure our network using OSPF. At the end of the tutorial we should be able to have full connectivity between all the devices connected. That is, we shall be using that topology that you're looking at on screen. We have 3 routers and 3 switches and 3 PCs. Each interface to a router, remember, represents a network. So in total, we have about 6 networks. We actually have 6 networks. Okay. Yeah. So basically, the IP addressing is how you see it on screen, and that is what we shall be following. Most of these between the routers, they are /30s, and the LANs are on. One is on a /29, another one on a /24, and another one on a /28. Okay, so we shall do the basic configuration, device configuration. We shall follow it by IP addressing. We assign IP addresses to all the interfaces. And then after that, we configure OSPF to achieve full connectivity. So let's get right into it. We start with the topmost, which is router 2. Okay, let me just resize this. Okay, so we begin. We shall configure the basics. Privileged exec. Global config, host name is R2. Okay. We secure our privileged exec mode using password Cisco. Remember, these passwords are just for demonstration purposes. In a production environment, please consider using a more secure password. All right, so we secure our console port. Password Cisco will be required when logging in. Then we disable the interaction and no exec timeout, such that we are not kicked out. We save this. What else can we do here? We can also do no IP domain lookup and banner message of the day. We can also do that. Authorized access only. Yeah, I think that's pretty much it. There are more settings that more configuration that we could do. But since it's not our main aim, we are aiming for OSPF. This should be good enough. Okay, we go to router 1. We do the exact same thing. Okay, enable, then configure terminal. We secure the privileged exec mode. Enable secret Cisco. And then line console. We secure the console port. Password Cisco. Login and then login synchronous. No exec timeout. And that should be it for that. So we secure the line BTY. I think we didn't do this for the other ports, but for the other router, did we give it a host name as well? We didn't. So we are also going to do that. Password Cisco. Yeah, login synchronous and no exec timeout. Okay, and then hostname is R1. Okay, no IP domain lookup. And banner message of the day, you can say authorized access only. Okay, and we save that. We go to R3. We do the same. Okay. All right. So enable conf terminal and hostname R3. Enable secret. Enable secret. Cisco. Password Cisco. Login. Synchronous. What else? No exit timeout. We exit that with 9 BTY. Line BTY 015. A password Cisco. Login. Login synchronous. And no exact timeout. We will do that as well. No IP domain lookup. And banner message of today, you can say authorize access only. Okay. And we save that. So that should be it for the basic configs. We go to IP addressing. So we have 3 interfaces connected to this R2. We have fast Ethernet 0.0 connecting to the LAN. We have this serial 2.0 connecting to R1 and serial 3.0 connecting to R2. So we are going to configure those with IP addresses. So we start with the fast Ethernet interface. Interface fast Ethernet 0/0. IP address, it's about 1. So we shall say 10.10.10.1.255.255.255.0. We'll bring it up with the no-shut command. And it has come up. So we got serial 2.0, 2.0, it's 2/0 rather. It is this interface here. I want to point it to you, that. So we shall give it a .2 IP address. 192, it's following this IP scheme. So 192.168.10.2. It's a /30, so 255.255.255.252. And then we'll bring it up. Okay. So it will come up when this other interface on R1 comes up. We exit there and then we say interface serial 3/0, which is this interface here. Which is this interface here. It follows this addressing scheme, so it will be a .9. So we shall say IP address, we give it an IP address of 192.168.10.9. 10.9, 255.255.255.252, and then we'll bring it up. Okay, just like the previous serial interface, it will also come up when the other side of the router comes up, when this side comes up. So we go to R1, we configure it. It also has 3 interfaces connected. The first Ethernet connecting to the LAN is a .17. Then the serial interface 2.0 connects to R2 is a .1, and 3.0 connects to R3, which is a .5. So we say interface first Ethernet 0/0 IP address of 172. Okay, this is what we are doing. 172.168.1.17. It's a /28. I hope you are familiar with your subnetting, but we haven't covered subnetting, but we shall cover it in a much later video. but a slash 28 is basically a 240, a dot 240. So we shall have 255.255.240. All right, and then we say no shutdown. All right, so it comes up, and the other side should also come up shortly. So we say interface. We now go to this interface, serial 2.0. We say interface serial. So you see, the other side also came up. Serial 2.0/0. IP address is 192.168.10.1. All right. It's on a /30, so that's pretty much easy. We bring it up. We bring it up. Let me see. Did we configure that? Okay. Yeah, that's basically no shutdown. And it should come up. Okay, and then we'll go to this final interface serial 3/0. We give it a .5. It is on it follows this IP addressing scheme, 10.4, so shall give it a .5 since it's a point-to-point. So we say IP address 192.168.10.5, 255.255.252. No shutdown. All right. So that's basically it for this router. We save our configuration and go to the final router. It's also on a 3 interface layout. We have the serial 3.0 connecting to router 2, which is on 8.10. We have the LAN, which is the fast Ethernet 0/0, and then we have a serial 3.0, I believe. Yes, serial 2.0 connecting to R1. So we begin with that. We say interface fast Ethernet 0/0. IP address is say .33. So we shall say 172.16.1.33. Now, if you remember, your addressing a /28 is a 240, and therefore a /29 is a 248. Okay? So we shall say 172. We shall say 255.255.255.248. You say no shutdown. Okay. And then we exit that. We configure the serial interfaces, and that will be it for these routers. Serial 2/0, which is this interface, this one here, it is a .6. So we are going to configure it the same way. So we shall say IP address 192.168.10.6. It's a /30. So we shall say 255.255.252. And once we bring it up, both sides should come up. So we go to the final interface, serial 3/0. So both sides came up, which is this interface here. It connects to router 2, and it's on a .10. All right, so we shall say IP address 192.168.10.10. Okay. And then once we bring it up, both sides should come up. So we can save, exit, and then we save. Okay, so that's it. All interfaces should be up. So what we are left with is assigning IP addresses to the PCs. This can be done using DHCP, but we haven't configured DHCP. We are concentrating on OSPF. So we shall configure this with a .10. We go to IP configuration. We give it a static IP 10.10.10.10. Okay, it's a /24. So we shall say 255 and 255. All right. Its default gateway is this interface here. All right. So we shall say 10.10.10.1. And it should be able to get off its network using that. So we go to PC0, or you can name it to whatever you want. It's a .20. That's what we decided to give it. So it's our we shall say 172.16.1.20, 255.255.255.240 /28. Its gateway is the .17, so we can just copy this and paste it here, and then change this to 17. And that should be it for that PC. We go to our final PC, which is a .35. There. So we shall say 172.16.1.35. And it's on a /29, so we give it a 255.248. All right, and its gateway should be this interface here. So we can just copy this, paste it there, and change this to 33. All right, so if this PC should be able to reach its gateway, and so should all the PCs. So let's just ping that, ping 172.16.1.33. If it doesn't, then there's a problem. All right, so we have success. We can test this as well, just to be sure before we continue. So we shall also ping 10.10.10.1, and we have success. Same as PC0 should ping the .17. We say ping 172.16.1.17. All right, so we have success. However, we don't expect it to be able to reach this 135. We can ping 172. We are pinging this PC here from this PC. So 172.16.1.35. So we shouldn't have success there, as you can see, destination unreachable, because it doesn't know how to reach that network. A simple trace route would show you where exactly the problem is. All right, so we start with router 2. We shall use the router command, router OSPF. We give it a process ID of 1. Okay. And we advertise the directly connected interfaces basically. So we shall say, we do that by saying network, just like in AIGRP. Network, which networks does it know of? We advertise all the LANs and all the serial interfaces. So we start with this. We say network 10.10.10.0. Now in OSPF, wildcard masks are a must. Remember in AIGRP, they were optional. Here they are a must. Now remember, a wildcard mask is the opposite of a subnet mask. So this is a /24. The wildcard mask is 0.0.0.255. Okay. Oh, I'm missing the area. We shall use an area 0. Okay. we advertise the next network, which is which one? Which one should we advertise? Let's advertise this one. So we shall say network 192.168.10.0. It's a 255. It's a 252. The /30, which is a 252. So the wildcard mask for that would be a .3, which is 255 minus 252, area 0. All right. And then we go to the final network on this router. Network, this one here. This is the network we are advertising, 192.168.10.8. All right. Wildcard mask is the same. 252, area 0. Okay. Invalid address, which one did I put? Right. We messed this up. Okay. All right, so it accepts that, and we can then exit. We are done configuring. We have advertised all the directly connected networks. We are now advertising them to all the routers, to all the other routers. So we can save that, and we do some basic checks to confirm that the interfaces, the networks are working, or the networks are being advertised. We could just do show. Let's exit here to make things easy. We show IP protocols. IP protocols. All right, so you can see that. Let me maximize this. You can see that the router ID is this. It automatically generates the router, the IP address, the highest IP address. Okay, and the gateway is also this, and administrative distance of OSPF, and then what we are advertising. Okay, those are the networks we are advertising. So that should be it. We come to R1. We do the same. We say a router OSPF process ID. This, you can use any number there, but why would you use any number? One is easy to remember. Imagine after a year you go back into this router and you're trying to remember the process ID. So always use simple is better. So router OSPF process ID is 1. We advertise our networks. So we shall advertise this, and that. So we start with the LAN. We shall say network 172, okay, .16.1.16, okay, and then we say 255.25. Oh, the wildcard mask, sorry, 0.0.0. Now what is /28 is a 240, so 255 minus 240 is 15, and that is we forgot the area, something I'm forgetting, area 0, and then we advertise the next network, which is this one, network 192.168.10.0/30. So that should be easy. All right, area 0. Okay, so you can see it has formed a full adjacency. So it went from loading to full, and the loading is done. It has formed an adjacency with neighbor. Process ID 1, neighbor 192.168.10.9. All right, this one here. All right, and then we'll go to the final network, which is this. We say network network 192.168.10.4/30, so that's a piece of cake. Area 0. All right, and then we exit and we save. Okay, so we go to the final router. We do the same steps, nothing changes. Router OSPF 1. We advertise the LAN. We say network 172.16.1.32. Correct? It's a /29, which is a 248. So we shall say 0.0.0.248 is it a 7? 5, 7, yes, I believe it's a 7. Okay, area, we forgot the area, area 0. All right, and then network 192.168.10.4/0.0.0.3. I keep forgetting the area, but you'll forgive me. All right, and then network, our final network is 192.168 the 10.8, the 10.8, 0.0.0.3 areas. This time I didn't forget it. Okay, and then we exit and we save. All right, so you can see it formed an adjacency. So we can just confirm we exit this. Let's maximize this. We say show IP route. We could start with that. So you can see it knows of 3 routes through OSPF. C is directly connected interfaces, those that the cable is running to. And then the O stands for OSPF. The legends are up here. You can see O is OSPF. It has learned of 3 routes. Let me just show you here. It has learned of the 192.168.10.0. This, it knows how to reach there. Okay. We have the administrative distance and the cost. I'm going to get into that. Then it also knows of this. And the final one, of course, is this. The final one is this 10.10. This 10.10, it knows of this. And it knows of this. All right. Yeah, the rest are directly connected, so we can also do show IP OSPF. Let me expand this. Show IP OSPF neighbors. All right, so it knows of these 2 neighbors, 10.5 and 10.9. This one is 10.5 and 10.9. Knows how to reach there. Which other? We could also do this is how you troubleshoot. So you show OSPF, show IP OSPF interface. We can also do that. Okay. You notice the router ID. Okay, it takes the highest of the 2. Okay. On this interface, it took the .6. So that's it. For OSPF, we can also configure the cost. But that is something you could also undertake by yourself. We can also change change the router ID to something we prefer. There's a lot we could change, but this should be enough to get us off our network. Those other ones, we can do brief videos for them, brief tutorials for them, just to show you how to change the process ID. So we should be now able to reach one another. Let me see. This is the gateway. I want to ping this PC, so we shall say 172.1.1.20. So we should be able to get there, just like you can see. That is OSPF working in the background. That has been configuring a network using OSPF. We could do another session where we go into the advanced settings for OSPF. We change the cost, we change the router ID and all that. But for now, this should be able to get you off your network. So I would like to thank you so much for viewing and for listening, and I'll see you in the next episode.